Welcome to clickmyproject.com. This video demonstrates an image processing concept about human object in painting using Manifold learning based posture sequence estimation. In this paper, we propose a human object in painting scheme that divides the process into 3 steps: human posture synthesis, graphical model construction, and posture sequence estimation. Human posture synthesis is used to enrich the number of postures in the database, after which all the postures are used to build a graphical model that can estimate the motion tendency of an object. We also introduce 2 constraints to confine the motion continuity property. The first constraint limits the maximum search distance if a trajectory in the graphical model is discontinuous, and the second confines the search direction in order to maintain the tendency of an object's motion. We perform both forward and backward predictions to derive local optimal solutions. Then, to compute an overall best solution, we apply Markov random field model and take the potential trajectory with the maximum total probability as the final result. The proposed posture sequence estimation model can help identify a set of suitable posture from the posture database to restore damaged or missing postures. It can also make a reconstructed motion sequence look continuous. The flow of the project starts with posture synthesis, followed by graphical model construction and posture sequence estimation. In posture synthesis, segmentation of the postures is done. Then, from the segmented postures, new postures are synthesized by combining the constituent parts. This posture synthesis method has low complexity and it offers to produce more postures with a limited set of configuration of body parts in the posture database. In graphical model construction, the postures are used to build the graphical model of the object's motion. The postures are projected to a feature space, and the postures that appear in the adjacent frames are linked together. Using a shape context descriptor, detailed description of each posture is obtained. The value of the shape context is used to compare the degree of similarity between 2 distinct postures. After calculating the similarity of the postures, we cluster all postures in the database using isomap. Here, the postures are given as input data points for isomap, and distance between them is the similarity between the postures. In posture sequence estimation, we obtain suitable postures and maintain objects' local continuity and global continuity. By this, we can identify a set of suitable postures from the posture database to restore damaged or missing postures and make a reconstructed motion sequence look continuous. Now we'll see the demo of the project. To execute, right-click on humaninpainting.m and select Run File. Click on Select Input Video button and you can click any video. So the video gets played in figure 1. Once the video has played, you can click on to Extracting Human Postures button. Once the postures have been extracted, you can check for its continuity. Next, we can reconstruct new human postures by segmenting the postures in the database. So for that, I am getting all the postures in the database. I have saved all the postures in the frame folder of the source code folder, and I click the OK button. So all the frames in the frame folder gets displayed here. Same list I want in list box 2 also. So I just click the second button here. So when I click this particular list, that particular image gets loaded in the first axis. When I click corresponding item in the list box 2, that particular frame gets loaded in axis 2. Now I am going to do two inpainting techniques such as fuse and reconstruct. So here I have fused two images, the selected two images, and again these same images I am going to reconstruct, that is replace the top portion of this image with the bottom portion of this image. So here the reconstructing steps are taking place. So here I have the reconstructed image, that is the top portion of first figure is replaced with the bottom portion of the next figure using inpainting technique. Next I select a particular image and I delete that particular posture. So that particular frame is deleted from the database. Now I want to reconstruct a frame similar to that frame. So I do graphical model construction. Once the graphical model is constructed, I can restore the missing posture. So here I obtained the restored missing posture, and once I have obtained the missing posture, I can reconstruct it to a sequence and make that particular video look continuous. So this inpainting process takes time, as it has to inpaint all the frames into a video. So here I get the motion sequence reconstructed using inpainting technique. From this demo we can conclude that for this inpainting algorithm we have used 3 steps such as human posture synthesis, graphical model construction, and posture sequence estimation. Thank you.